In this lesson, we're going to be talking about how to solve systems of equations using the graphing method. So first of all, when we say solving a system of equations by graphing, there are three things that can happen when you graph two lines. The first scenario is you get the two lines and they intersect in one point. So that point of intersection is the solution to the system. However, if there's no point of intersection, in other words, the lines are parallel to one another, that's when no solution occurs because there's no point of intersection. These lines are never going to touch. Therefore, there's no solution to the system at all. And then the third scenario that can happen is that one line is going to fall right on top of the other line. So technically, they intersect in every single point along the line to infinity in both directions. Therefore, we say they have infinite solutions. All right, our first example, we are going to graph the two equations listed to the left, y equals negative 2x plus 3 and y equals x minus 3. Now, we've spent time already talking about how to graph lines. So this should be review. Our y-intercept for the first equation is at positive 3. So I'm going to place a dot at positive 3. And then we're going to use the slope. I'm going to make that into a fraction. So I'm going to rise negative 2. So really I'm going to go down 2. And to the right, positive 1. And mark a dot. So if I connect those 2 points, hopefully in a straight line, there's our first equation. The second equation, I'm going to graph that in red. We see that it has a y-intercept of negative 3. 1, 2, 3. I'm going to mark a dot there. And then I'm going to use the slope, which the number in front of x for this particular equation is 1. So if I make that into a fraction, I'm going to rise 1 and run 1. And I'm going to connect these 2 points to make a line. I see that the 2 lines do intersect. However, it looks like they are not intersecting at a nice coordinate. So this is a great first example because sometimes when we graph lines, we don't quite hit the points that we wanted to, and maybe our lines aren't completely straight. So before I just take a guess at where this point is, right, I need the exact solution. So I'm going to go back up to my blue line and just make sure that I drew my line correctly and that everything's accurate. So from 3, I went down 2 and over 1. I'm going to continue to go down 2 and over 1. And we see right here that my point, my line that's in blue, is off. So if I were to graph that a little bit more accurately, I should see that, oh, these 2 lines are going to intersect at a nice coordinate. Now, guys, that's not to say that you won't ever get lines that don't intersect at nice coordinates. So that's one of the disadvantages of the graphing method. If they don't intersect in a nice coordinate, then it's hard to tell where that point of intersection is located. But at least for this first example, they are intersecting and it is a nice coordinate point. So that coordinate point is 2, negative 1. So we write our solution as a coordinate. Whoops, that was positive 2 and negative 1. So positive 2, negative 1 is my solution to this system of equations. All right, let's take a look at the next example. The next example, we see that the lines are not in slope-intercept form, they're in standard form. So I'm going to take a moment just to transform these into slope-intercept form so it's a little bit easier to graph. The first equation, x plus y is equal to 0. Let's subtract x from both sides. And we get y equals negative x. Let's take a moment to transform the second equation. I'm going to put this one on the right side of my screen. Y minus x is equal to 4. Again, we're going to solve that for y. So we're going to subtract x from both sides. We get negative y is equal to negative x plus 4. And we're going to divide both sides by negative 1. So I get y equals x minus 4. Okay, let's go ahead and graph those two equations. So in blue, I have the equation y equals negative x. There is no y-intercept in that equation, so we would have to think the y-intercept is technically 0. So I'm going to mark a point at 0. And then my slope is negative 1. If I make that into a fraction, I'm going to go down 1 and right 1. Because of what happened with the last example, I'm going to continue to go down 1 and right 1 until I have a whole bunch of points. And I'm going to continue to go up 1 and left 1 so I know where exactly those points are supposed to be. I'm going to try to connect those in a straight line, which close enough. All right. In red, I am going to graph the equation y equals x minus 4. So we see the y-intercept is negative 4. And our slope is 1. So I'm going to rise 1 and run 1. And we see that that point of intersection happened pretty quickly on that one. So again, we have one solution, and it is at the point 2, negative 2. So 2, negative 2 is the solution to my system. Okay, here's the next example that we're again going to take a look at together. We see that our first equation is already in slope-intercept form, so we do not need to transform that one. But the second equation is in standard form, so let's go ahead and transform that into slope-intercept. We're going to add 2x to both sides of the equation. And we get 3y is equal to 2x plus 6. Let's divide both sides of the equation by 3. And we get y equals 2/3 x plus 2. Okay, let's go ahead and graph both of those equations. So in red, my y-intercept is negative 1. And the slope is 2/3. So we're going to rise 2 and run 3. I'm going to also go down 2 and to the left 3. So there is my first line. In blue, we are going to graph the equation y equals 2/3 x plus 2. So my y-intercept is 2. And the slope is 2/3. So I'm going to rise 2 and run 3. Down 2 and left 3. And there is my second line. Notice, ladies and gentlemen, that these two lines are not intersecting. And even if I were to extend those on forever in both directions, both x direction and y direction, they are never going to intersect. They are parallel to each other. You can tell that two lines are parallel by looking at their slopes. So taking a look at these two slopes, I see the slope is 2/3 on both equations. We had talked previously that if we have parallel lines, they will have the same slope. So if you notice that, you can just say that there's no solution automatically. You don't even really need to graph them. So this example has no solution because, again, there's no point of intersection. The next example, again, we're going to graph. So the first equation is already in slope-intercept form, but the second one is not. So let's go ahead and transform that. Let's subtract 4x from both sides. And we get 2y is equal to negative 4x minus 2. We're going to divide both sides by 2. So we get y equals negative 2x minus 1. All right, graphing the first equation, which is in purple, I have a y-intercept of negative 1, and the slope is negative 2. So I'm going to go down 2 and right 1, and I'm going to put a couple more points on the graph so I make sure my line is straight. And there's my first line. Okay, second equation, I'm going to plot in blue. We have a y-intercept of negative 1, and we have a slope of negative 2. So I'm going to move down 2 and right 1. Notice these points are on my original line. So these two lines are the exact same graph. So every single point is going to be a solution because the lines fall right on top of one another. So we say infinite solutions or infinitely many solutions. Sorry, it's really hard to write on this screen with my finger. So infinitely many solutions or infinite solutions when the two lines fall right on top of each other. Okay, here's the next example. Both of these equations are in slope-intercept form, so that's really nice. The first one I am going to graph in blue. We have a y-intercept of positive 1, and the slope is negative 3/2. I'm going to mark a couple more points by going down 3 and right 2, or up 3 and left 2. So there is my first line. Ooh, it's a little crooked. Sorry about that. All right, the next equation, the next line, I'm going to plot in red. We have a y-intercept of positive 3, and our slope is 1/2. So I'm going to rise 1 and run 2. Again, I'm going to go in both directions. So I make sure to make a straight line. Even though my lines are technically not exactly straight, but close to it, we see the points that were originally marked, and there is no nice coordinate. These are meeting in between two coordinates. So this shows us a disadvantage of using graphing method. We don't know exactly where these two lines meet because they're not meeting at whole integer numbers for the coordinates. So no worries, guys. We'll be learning more methods for how to solve systems without graphing in the next few lessons. So for right now, we know that this system has a solution, but it's really hard to tell exactly where it's located. I could guess maybe -1 2 point something. But again, it's really hard to tell. So this is just kind of my way of saying, don't worry about it. We'll eventually get some other methods. And maybe graphing method isn't the best method to use, at least most of the time. Okay, this is the you try slide. So I gave you one equation in slope intercept form, but I gave you the second equation in standard form. So you are going to need to transform that second equation into slope intercept form. I'd like you to graph both of those lines and find the point of intersection or the solution. Pause the video here and then unpause the video when you're ready to see the results. Okay, we see that the first line is in red. It had a y-intercept of -2 and a slope of 1/3. So rise 1 and run 3. The second equation, if we transform it into slope-intercept form, it looks like y equals -x plus 2. So it has a y-intercept of +2 and a slope of -1. So we go down 1 and right 1. And I see that these two lines meet, and the coordinate that they meet at is at 3, -1. So that is the solution to this system.